And we can estimate that on our calculator if we want to. Let's go ahead and do that. Turn on our TI-83 here. Square root of 3, we can figure out what that is. So we hit the square root of 3, approximately 1.732. And we can store that in memory. We can hit Store button and the X. So now it's stored in memory. So we can write 2 plus X and divide that by 2. The answer is 1.866. Then we can write 2 minus X and divide by 2. So 2 minus X and divide that by 2. 0.13397 or 1340. Now knowing these points will help us in sketching the parabola. So our parabola must go through the points 1.866 and 0.1340. So right here, there's my x-intercept there, and my other x-intercept is 1.8. So if that's 1 and that's 2, then 1.8 would be about there. So knowing those points allows us to get a more accurate sketch of our quadratic function. We can go through the x-intercepts and then come up with a good sketch. If you have the vertex, if you have the x-intercept, and if a few more representative points, usually 5 points are all that is needed to find a good sketch. Now the other questions we want to ask is, what is the domain? Well, the domain of any quadratic function will always be all real numbers. So down here, we'll go on the left side, we'll say the domain will be negative infinity to positive infinity. Now the range we're going to determine from the graph. The range is the values of y. So from the graph we see that the graph reaches its peak at 3 and doesn't go any higher. And so the range will extend from 3 to negative infinity. But we write it from low to high. We write negative infinity on the left, 3 on the right, and put a bracket around the 3. Now this brings up an important point about quadratic functions. Quadratic functions have what we call the vertex, and the vertex of a quadratic function will be a key point on the graph, because the vertex tells us what the maximum value of the quadratic function is if it opens down, such as the case here, or if the parabola opens up, it tells us the minimum value of the quadratic function. So we can find either the maximum value of a quadratic function which opens down, or we can find the minimum value of the quadratic function which opens up simply by finding the vertex.